In 2025, the world is obsessed with artificial intelligence. ChatGPT writes essays, AI generates art, self-driving systems navigate cities, governments debate regulation, companies pour in billions. But behind every breakthrough, behind every model, behind every revolution, there is one silent force, and that force has a name. Jensen Huang. You might not see him trending every day. He's not constantly in political debates. He's not tweeting controversy. But without him, there is no AI boom. Because while others built the brains, he built the engine. And in the age of intelligence, the engine is everything. To understand why Jensen Huang might be the most important man in AI, we need to go back. Not to ChatGPT, not to OpenAI, not even to Google. We go back to 1993, a small Denny's restaurant in California. 3 engineers sit in a booth. Big ambition, limited resources, zero guarantee of survival. One of them is Jensen Huang. They decide to start a company. Its mission? To build graphics chips for video games. Nothing about artificial intelligence, nothing about transforming civilization, nothing about trillion-dollar valuations, just graphics, just pixels, just gaming. The company's name? Nvidia. At the time, it was just another semiconductor startup in Silicon Valley. But Jensen Huang wasn't thinking small. He believed something radical. That computing would not move forward by doing things sequentially, but by doing many things at once. Parallel processing. Instead of one brain solving one problem, thousands of smaller units working together. It was perfect for rendering 3D graphics, explosions, shadows, textures. Gamers loved it. And Nvidia grew. But what Jensen may not have fully realized was that he had accidentally built the perfect architecture for something far bigger than gaming. Because years later, AI researchers would discover something powerful. Training neural networks, the foundation of modern AI, requires massive parallel computation. Exactly what GPUs were designed to do. The same chips that made video games beautiful could make machines intelligent. And that realization changed everything. But here's where the story gets interesting. In 2006, Nvidia made a decision that would quietly reshape the future of AI. They launched something called CUDA. CUDA wasn't just a chip, it was a platform, a software ecosystem that allowed developers to use Nvidia GPUs for general-purpose computing, not just graphics, computation, scientific simulations, physics, machine learning, and most importantly, deep learning. At the time, almost nobody understood how important this would become. AI wasn't mainstream. Neural networks were still considered niche. Many researchers were skeptical. But CUDA gave early AI pioneers something powerful, a way to train models dramatically faster. Suddenly, experiments that took weeks could take days. And researchers started building on Nvidia hardware. Then something subtle happened. As more researchers adopted CUDA, more tools were built for CUDA. As more tools were built, more researchers adopted it. And before the world realized what was happening, Nvidia wasn't just selling chips, it had created lock-in. Switching away would mean rewriting entire systems, rebuilding research pipelines, re-engineering infrastructure. In technology, that kind of ecosystem advantage is almost impossible to break. Jensen Huang didn't just sell hardware, he built the foundation. Fast forward to 2012. A deep learning breakthrough shocks the academic world. Neural networks suddenly outperform traditional systems in image recognition. And what were they trained on? Nvidia GPUs. From that moment on, AI stopped being theoretical. It started becoming practical. Companies took notice. Investors took notice. Governments took notice. But Nvidia was already positioned, already embedded, already essential. Then came the moment that changed everything. ChatGPT. When OpenAI released ChatGPT to the public, it wasn't just a viral app, it was a signal. AI had crossed a threshold. Millions of people experienced machine intelligence firsthand, and companies panicked. They realized they needed AI immediately to compete, to survive, to dominate. And what does AI require? Compute. Massive compute. Data centers filled with powerful GPUs, the most powerful of which were made by Nvidia, specifically the H100. Suddenly, demand exploded. Tech giants scrambled to secure supply. Startups raised billions to buy clusters. Cloud providers raced to expand capacity. And Nvidia became the most important supplier in the entire ecosystem. This wasn't gaming revenue anymore. This was infrastructure for intelligence. Every major AI company, OpenAI, Google DeepMind, Anthropic, Meta, all relied heavily on Nvidia. The gold rush had begun. But Nvidia wasn't digging for gold, it was selling the tools, owning the supply chain, controlling the engine room, and when you control the engine room, you control the pace of the revolution. By 2024 and 2025, Nvidia's valuation surged past $1 trillion. Jensen Huang, once a relatively quiet CEO in a leather jacket, became a symbol of the AI era. Governments started paying attention. Because GPUs were no longer just commercial products, they were strategic assets. The United States began restricting exports of advanced Nvidia chips to China. Why? Because whoever has the most powerful computing has the advantage in AI. And whoever leads in AI may lead in economic power, military capability, scientific discovery. The humble gaming chip had become geopolitical leverage, and Jensen Huang was at the center of it all. But here's the deeper reason he may be the most important man in AI. It's not just about chips, it's about vision. For decades, Nvidia invested in a future most people didn't see. They reinvested into research, into architecture, into software tools, into developer ecosystems. While others focused on short-term profits, Nvidia built long-term dominance. They didn't pivot to AI after it became popular. They were already there, prepared, in position. That's not luck, that's strategic patience. Now think about this. OpenAI builds powerful models. Microsoft integrates them into products. Google competes with its own systems. Startups innovate at the edges, but all of them run on Nvidia. It's like the early days of electricity. You can build the best factory in the world, but without power, it doesn't run. In the AI era, compute is power. And Nvidia generates it. Some argue competitors will eventually catch up. AMD, custom AI chips, cloud-designed processors. And maybe they will. But ecosystem advantages are hard to break. CUDA has years of developer loyalty. Toolchains are optimized for Nvidia. Entire research communities are built around it. Replacing Nvidia isn't just about building a faster chip. It's about rebuilding an entire world. And that takes time. Time the AI race may not allow. So what does this mean for the future? If AI becomes the defining technology of the 21st century, then the companies controlling compute may become the most powerful companies in history. And the man who positioned his company at the center of that infrastructure becomes more than a CEO. He becomes an architect of the future. Jensen Huang didn't set out to control artificial intelligence, he set out to make graphics faster. But through strategic thinking, ecosystem building, and long-term vision, he built the engine of the AI age. And in revolutions, the engine builders often matter more than the frontline inventors. Because without the engine, nothing moves. So next time you hear about a new AI breakthrough, a smarter chatbot, a revolutionary model, a company raising billions, remember this. Behind the scenes, in massive data centers, rows of GPUs are humming, processing, training, calculating. And somewhere at the origin of that power is a decision made in 1993. A bet on parallel computing, a platform launched in 2006, and a CEO who believed the future belonged to accelerated computing. His name is Jensen Huang. And whether the world realizes it or not, the AI revolution runs on his architecture. And this is only the beginning, because as AI models grow more powerful, they will demand more compute, more energy, more infrastructure, which raises a new question. In the race to build superintelligence, who truly holds the leverage? The ones writing the algorithms, or the ones supplying the engine? The answer may shape the balance of power for decades to come. And if that's true, then Jensen Huang may not just be important, he may be indispensable.